Hello all, this video is all about MSP430 architecture. So this is a continuation of the previous video. So here MSP430 G series memory map is given in the table. So the memory size can be 1 KB for MSP430 G2153. But for 2253, 22113, so the memory size can be 2 KB. So based on the necessity and based on the application of the embedded system, we can select the microcontroller. 353 microcontroller will be having a capacity of 4 KB. 413 will be having a memory capacity of 8 KB. 553 and 513 will be having a memory capacity of 16 KB. So the flash memory ranges are given. The information memory ranges are given. Random access memory ranges are given. So random access memory for 153, 253 and 353 is going to be the same. The peripheral devices which can be connected with the microcontroller is also given in the block diagram. So memory organization or the flash. MSP430 flash memory is partitioned into segments. A smallest size of flash memory that can be erased, and it can be reprogrammed also. The flash memory is partitioned into main and information memory sections. The differences between the two sections are the segment size and the physical addresses. The information memory has a 464 byte segments. The main memory has one or more 512 byte segments. So when we learn more about the memory organization or the flash memory, so we have seen that the memory range is in the series of 0 cross 0000 till 0 cross FFFF. So in 0 in this memory address location, the special function registers would be there. Next, from 0 cross 0100 to 0 cross 00FF, peripheral registers will be there. 0 cross 0100 to 0 cross 01FF, peripheral registers in the form of word access would be there. 0 cross 02 FF00, 0 cross 027F will be having the random access memory. So likewise, the bootstrap loader will be there, flash information memory will be there, flash code memory will be there, interrupt and reset vector table will be there. The start address of the flash read-only memory depends on the amount of flash read-only memory present and varies by device. The end address for flash read-only memory is from 0 cross FFFF. For devices with less than 60 KB flash read-only memory, flash can be used for both code and data, but is generally used as code memory. The code memory holds the program. The interrupt vectors are used to hold the interrupts. The interrupt vector table is mapped up to the upper 16 words of flash read-only memory address space with the highest priority interrupt vector at the highest flash read-only memory word address. So interrupt vector address table is given here. So next one is the information memory is 256 bytes. Block of flash memory that is intended for storage of non-volatile data. So we will be storing the data in this flash memory. Memory address will be in the range of 0 cross 1000H to 0 cross 10FFH. The information memory has 4 segments of 64 bytes each. So segment A contains factory collaboration data for DCO in MSP430 G2553, which is an advanced microcontroller. After reset, segment A is protected against programming and erasing. Actually, what we do is like the memory is divided into segments. Segment A will be programmed. After programming, after completing the program, the segment A will be completely protected, and then we will be programming the next segment. Bootstrap loader memory is a 1023B block of flash memory that is intended for a storage of non-volatile data. Memory address range will be in the will be from 0 cross 0C 00H to 0 cross 0F FFH. Bootstrap loader memory space contains code which is invoked when the controller enters into BSL programming mode. So that is also possible. Memory organization, random access memory. So the random access memory is used for data and variables. Random access memory starts from 0 to 00H. The end address of random access memory depends on the amount of random access memory present and varies by device. So this 2553 microcontroller will be having 512 bytes of random access memory. So the peripheral registers are used. The address space will be in the range of 0100 to 01FFH. So these modules will be used for accessing the word instructions. That is why they mentioned as word access. So the details of the peripheral registers and the address in the peripheral file map in the data sheet, which was shared before. I hope you would have found the video to be useful. See you in the next video. Until then, it's bye from Radhika.